Hello, everybody. I'm Richard Esplin. This is another Evernym sprint demo. It is February 13th. This is our second complete sprint. For 2020, we finished the 2019 sprint earlier in January, and we post this as usual on our YouTube channel every 2 weeks. So if you're watching this, you can check out previous videos in our playlist, get a background of the project. This is about all of our contributions to the Hyperledger projects, and we've been working on a number of internal improvement tasks, a lot of team tasks in the past couple of weeks, but we still got some good stuff done. I'm excited to be able to show stuff. So today we're going to be talking about some work we did for a customer, and we're able to contribute that work upstream in LibVCX and how we handle proofs and connections there. So Nikita will be showing that. We had a number of requests by customers to better understand what was causing network connection problems between Connect.me, our mobile wallet, and the Indy Node pool on the back end. They want to be able to tell, they open all the ports, yes, things still get dropped. Is it because there's deep packet inspection trying to block ZeroMQ traffic, or what is the concern? So we build a tool to help identify and isolate that. We'll be showing that. At this point in time, the Sovrin network's been used in production for a while, but there are a couple other Indy networks. There's one in Scandinavia called Findy. There's one in Africa that's being run by Kiva. There are a couple others we've heard of. Don't know those teams yet. We want to make sure we have clear documentation on how to troubleshoot these networks, how to administer these networks, so that people can benefit from our experience. And so we put that together. Sergey's going to go through that. And we've been working very closely with the team at the Sovrin Foundation to add the new functionality that was standardized as part of the W3C verifiable credentials working group to do rich schemas, encodings, proof presentations. We're bringing that to Indy. That works well underway, and we'll get an update on that as well. So that's the plan for today. As far as the sprint details, as I said, we've been doing a number of internal items. So on the SDK side, we completed some bugs, but most of our focus has been on that customer work that we've been able to bring back to upstream and make sure we have clean CI/CD and testing, things like that. Did some dependency updates, general things. Next plan for the sprint, we want to release in the coming sprint on the SDK side. We want to release the bug fixes. It's probably going to be a small release in February, but we'll get out what we've done. We haven't been terribly happy with the Jenkins pipeline. I mean, it works, but it hasn't improved in a while. And Jenkins isn't as fast-moving a project as say GitLab, and there's some new capabilities at Azure and at GitHub. We need to figure out what we're going to do about CI/CD, especially as we integrate the rich schemas work. And people who've been watching the Indy contributors call, that's in the you can check in the wiki for Hyperledger, the Indy contributors meeting. We do that every other Monday. There's been conversations about taking libindy and breaking into pieces, so those pieces can be consumed by Aries frameworks. And the first piece of that is created Indy VDR. That was done by Andrew Whitehead at British Columbia. That work's maturing pretty well. Andrew needs to do some additional testing, or the team at British Columbia, some additional testing and get the repo moved to Hyperledger. But you can see in 1499, there's a link to where the repo is now. We want to remove that code, deprecate that code in libindy, and call this VDR. That means it's got to have CI/CD set up, and we're not sure where to do that. So we need to do some of that research, make that decision, and then we can start putting the rich schema stuff in there, and there'll just be one code base to maintain. So we're excited about that. We have some bugs we plan to work on, and then we need to do our part of we like that people are excited and moving libindy into the Aries architecture, but we want to help with that as well. So we're going to work on the wallet implementation and pack unpack. We expect to move some of those. I don't know if that'll happen in the next couple weeks or if that'll be an early March thing. We hope anybody who wants to work on those with us, we'd love to work with you. Just reach out at chat.sovrin.org or chat.hyperledger.org. Either one, we hang out on both. But that's the plan for the next 4 weeks there. On the Indy Node side, we've been focused on, you know, most of that stuff we just said we demo. There's also been an effort, we've been collaborating with the team at Kiva and the Sovrin Foundation to replace Indy Crypto with Ursa on the Node side. That's taken a lot of work because we got to move Plenum and the Indy Node at the same time. We have to make sure that the CI/CD, specifically the package repositories, work properly. So we're working on that. And we've been doing some research of other ledgers to make sure we're well informed. The next batch of work is all about rich schemas. We want to get this work done, but that needs to move in tandem with the, you know, that's a bit tied in with how we want to handle the VDR and libindy. We're ready to take some of that work up the stack, and so we'll probably be doing more work on that tier in the next little while. And if we see a bug or something, we'll pick that up too. So that is the plan for the next little while. So with that, let's get into the plan for today. So I'll stop sharing and let Nikita share. Okay, we see your screen, Nikita, but you're still on mute.
Yeah, so I came off mute finally. So
excellent, thanks.
As the last 2 weeks, almost, we spent on open sourcing some features that Evernym provided us that we can move to the upstream. The main two features are proof reject and connection redirect. Proof reject is similar to the proof decline in Aries workflow, but it works with the old LibVCX protocols that use, I think, that were originally in Verity and Agency. So how does it work? If so here's the test for this functionality. So if somebody makes you a proof with some credential and you are not satisfied with it, you can reject it, and this person will receive a message that his or her proof is not accepted. Then the connection redirect is a bit more complex thing. This functionality is not represented in Aries protocols, but it may be introduced somehow and somewhere in its protocol in its protocols. That's how it works. For example, Alice and Faber had a connection between them, and after that, so they have a connection. Then after that, they've created Faber for some reason forgot about its connection to Alice and created a new one and sent an invite to Alice with some secure channel or not secure. And then Alice receives this invite and understands that she already has a connection with with Faber because she knows his public DID, and then she redirects this connection to Faber. So Faber acknowledges that he knows he already has a connection with Alice and starts chatting within the old connection. What I can add about proof reject is that the API might change in future. Right now we have 2 calls in VCX. One is for proof decline in Aries, and one is for proof reject for the agency. And we don't have now any, how to say it, vision what will it look in the future, but it might change, so use with cautious, please. I think that's it.
Thank you, Nikita. It's really nice to be able to see that contribution come all the way back into the upstream. And Andrew, let's talk about ZeroMQ connectivity.
Hello, everyone. Let me share my screen. Can you see it? Yeah?
Yeah, looks good.
Okay. I'm going to tell about some tool which can help to diagnose connections, TCP and the ZeroMQ connections between two remote nodes, for example. Now I have two Docker containers which are placed in the same Docker network. Well, the tool consists of two parts. First, it's a client, and the second is a server. We have two type of checks. Firstly, we should check a TCP connection, and then we will try to check a ZeroMQ connection. Server side consists of that stack like okay, no, server is it's like a plenum's that stack implementation, which independent of plenum. But I try to save all of the stack functionality for this. Well, let's try. Server listening 10,000 ZeroMQ port and 9999 TCP port. In the positive case, we send diagnostic message through TCP socket and got reply, and also we create a ZeroMQ connection and also send the diagnostic message through the ZeroMQ socket and get reply. All are happy and all looks fine. But let's try to emulate some situations when we had connection problems. For example, we can drop TCP connections, or TCP connection using IP tables, and as expected, we have TCP connection problems. For example, I think we need to check what's going on. Let's return back. This looks fine. And okay, it's working. Now also, I apologize, but I didn't find any clear method for blocking ZeroMQ connection. But let's imagine that this way is acceptable too. We are blocking input connection for ZeroMQ port, and TCP check passed, but ZeroMQ check will be waiting for a response. And if we return back our rules, yes, we can see that the ZeroMQ connection not possible. Sorry. Well, as a future plans, I will create a small scripts which can help to deploy these scripts on all of checking site. I think it's all from my side. Thank you.
Excellent. Thank you for showing. That tool is going to be really useful. We'll be taking that to our customer success team and getting some feedback, and that's going to be great. Thank you for that. Alex, let's talk about rich schemas.
Hey, should we talk about troubleshooting first, or?
Sorry, troubleshooting. I looked at the wrong line of the list. Yes, Sergey, let's talk about troubleshooting. Thank you.
Okay, can you hear me?
Yes.
And hopefully you can see my screen too.
Yes, we can.
Yes, great. Well, during the sprint, among other tasks, we had task on creating a node troubleshooting guide. Currently, we have a PR raised. Hopefully, we can close it by the end of the sprint. This means by tomorrow. There is already quite a big document on that topic, and it will be expanded further. So what can you find in this document? First of all, I tried to provide some background info with a minimal description of RBFT consensus, so that somebody who tries to diagnose some problems with Indy Node can at least somewhat understand what's going on. So what is validator node, what is pool, why we call processing our transactions ordering, what is master primary, and what are thresholds of failures. Next, there is a section on types of failures with different levels of severity, from just environment problems which can go away to ledger corruption, which will require messing with ledger data in order to fix it. Then there is a quick overview of sources of data where you can get info from quickest to the hardest things. So the quickest way is to just run validator info command and get some overview of current nodes health state. Then it could be very quick to look at journal CTL logs, which can show some crashes if there were any. And then it's recommended to delve into Indy Node logs, which sometimes can be huge or intimidating, but there are tools with links to them. And actually, we had some node processing tool, well, node logs processing tool written, well, quite a lot of time ago, but it actually has a documentation, and probably it also could be of some help. But honestly, we are using grep most of the times recently. And then comes a troubleshooting checklist. I started with the most severe problems about ledger corruption and how to diagnose them, how to understand which nodes were corrupted and what to do next. And there is now a short section on useful patterns to look for in logs, which can really help in understanding what's going on. And actually, these two sections will be expanded by the end of the sprint. So that's all from my side. Any comments, questions are welcome.
That looks really useful. That looks really useful. I've never used the ripgrep tool. I'm going to play with that. This will be good. And of course, anybody who's watched this video, if you have suggestions for improving this, pull requests are most welcome. and it'll be good. Mind if I take over screen share for a minute?
Well, actually, as for grep, it's just a grep written in Rust, and it's really fast and can just use multiple cores, unlike original grep utility. And I find it very useful when analyzing especially big amounts of logs.
Yeah, it's got some additional flags and things I was noticing. Always like a new bash tool. That's very nice. So I was going to take over screen sharing for just a minute to invite everybody. Now that we have this document written, thank you, Sergey. We put together a special Indy contributors meeting on the 25th. Due to holidays in the US and Russia, our normal Monday times, we're not going to have everybody together. But sorry, not the 25th. Special troubleshooting in Indy network. We're going to do this at 3 p.m. UTC, and you can see the Zoom link there. And we'll go through this document. We'll show some examples of logs, and we'll share best practices. And we hope anybody who's maintaining an Indy network can join us on that call and make sure we make your lives as easy as possible. And if you have specific questions, please reach out to me in advance so I can make sure that we write it down and add to the agenda. Or you can just put it in the agenda. That works too. Edit the wiki and put any specific questions you have. We'll make sure to get those answered. Prepare in advance to make sure it's a really productive conversation. So thank you for that. And now we'll talk about rich schemas.
Yeah, thank you. So this sprint, we started the work related to rich schemas, and the first thing that we decided to start is to create a design to find what is common in rich schema objects and how it can be implemented on the both ledger side and the client side. There are two pull requests. There is a pull request to Indy HIPE with rich schema objects common HIPE here, and to Aries RFC, approximately with the same content but applied to the Aries project. So I would like just briefly discuss what's in this document. This document answers the questions, the general questions applied to any rich schema objects. For example, how the schema objects are identified, how they're referenced, what objects are mutable, immutable, are there any general patterns around them, and so on. And the goal is to have a sufficient amount of information to proceed further, to start implementation. I'd like to mention that there are some unresolved questions, the questions which are discussed within the Indy and Aries community, but I believe this is enough information to continue working on rich schemas next sprint and continue discussions and resolving all these questions on Indy contributors and Aries working group calls. I will just briefly discuss what we are proposing in this document. We're discussing the immutability of rich schema objects. In particular, some rich schema objects are considered as immutable. Some of rich schema objects are considered as partially mutable, with the comments what consequences can be there. As for identification of rich schema objects, what community agrees about that any rich schema object should have a unique ID. In these HIPEs, we propose a DID as this unique ID. I would like to mention that there is no 100% consensus in the community around this, so anyone who is interested in the topic are welcome to share your opinion. But that's the current proposal, and the HIPE contains some rationalities about why we are proposing this. Also, we are providing a relationship diagram for all rich schema objects and how they reference each other, actually just by ID, which can be a DID. And here I propose a very simple and generic structure how any rich schema object is stored on the ledger. So it consists of the content, as is, and some metadata such as name, version, type, and ID, of course. And this format allows to deal with all rich schema objects on the both Indy Node and client side in a similar way. And I believe can speed up development and speed up creation of further hypes related to specific of every rich schema object and examples of every rich schema objects. Yeah, there are some examples about different methods, about format for requests, for replies, transactions. So I believe that's it. So anyone who is interested in this, please feel free to have a look at these pull requests and participate in these discussions during our Indy contributors and Aries working group calls.
Thank you, Alex. And that'll be really useful. We expect to see this work moving up the stack over the next couple of weeks into libIndy, Aries VDR, or the Indy VDR, and all the way up into Aries clients over the next six to 8 weeks. So that's going to be, these features are long awaited. That's everything for today. Thank you very much. Of course, you can reach out to us. You can track the backlog in Jira, and you can reach out to us at chat.hyperledger.org, where we hang out in the #Indy channel and the Indy Contributor Scan channel. And as I mentioned earlier, we work a lot with Sovrin Network, so we hang out at chat.sovrin.org as well. So with that, we'll post another video in 2 weeks.